السلام عليكم، بسم الله الرحمن الرحيم. اهلا يا شباب. النهارده ان شاء الله اخر شابتر هناخده في Analytical Chemistry 1. الجزء الاخراني عباره عن البارت بتاعنا اسمه Chemical Kinetics او الشابتر اسمه Chemical Kinetics. و Chemical Kinetics is an introduction to pharmacokinetics specialty, which you will study in details in pharmaceutics in higher levels. I think maybe in level 2 or level 3 maybe. You will be given the detailed relationship between kinetics and medications or drugs, or the science that we call pharmacokinetics. So chemical kinetics will be just an introduction with some major points that you will need to apply on drugs later in pharmacokinetics. The definition to chemical kinetics. Chemical kinetics is defined as the branch of chemistry which deals with the study of rate of chemical reactions and mechanisms of chemical reactions. So we will be studying the rate and the mechanism of chemical reactions and how they are related. Studying the rate of chemical reaction and rate law during the course of chemical kinetics is very important for four main reasons. Number one, it shows the time needed for a given amount of the product to be produced. احنا لما بنعمل chemical reaction خصوصا الرياكشنز اللي بتبقى يعني ليها هدف تجاري، زي مثلا في مصانع الأدوية أو في الشركات، أو حتى لو عندنا في المعامل البحثية بعمل رياكشن ومطلوب إن أنا بعمل production ل certain compound. وطبعا غالبا ال certain compound دوت بيكون pharmaceutical أو يعني an active drug. لما بنعمل الرياكشن احنا محتاجين ان احنا نعرف الكومباوند دوت او certain concentration منه هنحتاج وقت قد ايه عشان ننتجه، لان الوقت طبعا بيبقى عامل مهم جدا للبروفيت، الربح المادي. كل ما وفرت وقت كل ما الربح بتاعي زاد او البنفيت او البروفيت زاد. Chemical kinetics or studying the rate of chemical reaction shows the amount of product in a given amount of time, the opposite to the first point. In the first point you have a fixed amount, or you have known the amount of product needed and you ask for the time. In the second point it's the opposite. You have the time to be applied or to be allowed for the reaction, and you are requesting the amount of product to be produced. Number 3, how to control the reaction, to have the upper hand on the reaction. يبقى لينا control على reaction, to enhance the speed of the reaction, to slow down the reaction, to give explanation about the need for using a catalyst or an enzyme to enhance or to accelerate the chemical reaction. And finally to give us a guide towards the mechanism of the reaction. يبقى دي البوينتس اللي تهمنا في purpose for studying chemical kinetics. يعني احنا ليه بندرس chemical kinetics؟ ليه بندرس rate of chemical reaction والmechanisms of chemical reaction؟ عشان 4 points دولت. وطبعا احنا يهمونا لما تكون البوينتس ديت related to drugs. يمكن احنا السنة دي واحنا بندرسها او احنا بنتكلم فيها دلوقتي هنتكلم على generally chemical reactions، اي chemical reaction، لكن احنا طبعا كفارماسيست يهمنا ان احنا to apply الحاجات دي كلها على الميديكيشنز او الفارماسي. طيب هنبتدي اول حاجة بالديفينيشن of the rate of a reaction. طبعا when we say rate we understand it's an amount that's related to time. It's something that's related to time factor. So the definition for a rate of a chemical reaction, it's the amount of the product or the amount of the reactant used up per unit of time. يبقى احنا هنقيس the product formed, amount of product formed, or amount of reactant consumed or used up in a unit of time. هو لو product يبقى ال concentration بتاعه by time increase، ولو reactant يبقى ال concentration بتاعه by time will decrease. It's the increase. فممكن نقول ال rate in another form of definition أو in another way we can define it in another way. It's the increase in molar concentration of the product per unit time or the decrease in molar concentration of reactant per unit time. يبقى البرودكت طبعا كل ما زاد وقت الرياكشن بيزيد كمية البرودكت اللي بتتكون، فالريت هو الانكريز in the product form. والرياكتنت بيستهلك it gets consumed or its concentration decreases by time, so rate is the amount of reactant decreasing or consumed up per unit time. We can give or we can use another form of definition for the rate of chemical reaction. It's the rate at which a species loses its chemical identity at particular volume per unit time. يبقى هو اللي change في chemical nature of a compound per volume per unit time. بنثبت الفوليوم بتاعنا ونشوف التشينج في الكيميكال كاركترستكس بتاعت الكومباوند بير يونت تايم. Let's stick to the previous definitions. It's increase in products or decrease in reactants per unit time. This is the most precise and the most common definitions to be used for the rate. What is the unit of rate? If we are calculating the rate for chemical reaction, what would be the unit of rate? It's, of course, we know it's amount per time. What is the amount? It's change in concentration by increasing or decreasing. So the unit would be concentration divided by time. And we are dealing with the molar concentration. احنا هنتعامل بالمولر concentration. طب المولر concentration اللي هو يا اما بنكتب M capital يا اما بنقول مول per liter. يبقى هيكون مول per liter per second، يعني مول liter minus 1 second minus 1. Let's take another example. Let's deal with another example so that we can understand the concept of reaction rate. الجاز دوت يا شباب او الكومباوند دوت ده الداي نيتروجين بنتوكسيد. نقرا كده النومنكليتشر بتاعته. داي نيتروجين بنتوكسيد ده molecular compound بنقراه بعدد الاتومز. This compound is the di nitrogen pentoxide. Two molecules of this gas react to produce 4 molecules of nitrogen dioxide and 1 molecule of oxygen gas. For this reaction, it could be found by the rate of this reaction can be found by measuring the increase in molar concentration of oxygen or increase in the molar concentration of nitrogen dioxide. Both are products. So this is the reactant and these are the products. So the rate of such chemical reaction would be equal to the change in oxygen concentration per time or change in nitrogen dioxide concentration per time or the change in dinitrogen pentoxide concentration by time. You know the sign delta, this triangular sign, it means change in. Okay, so it means that we subtract the initial value or the initial concentration minus the final concentration. وهيبقى عندنا التايم هنا هيبقى change، يعني برضو هيبقى difference in time. So when we calculate the rate, we use the change of time and the change in the concentration of one of the products. Mostly in this case, we use the concentration of oxygen as a variable during the reaction. يبقى هنا في الرياكشن ده تحديدا بنتعامل مع الاكسجين باعتباره واحد من الفاريبلز اللي موجودين، وبما انه هو برودكت فبيكون الديفرنس عندنا الكونسنتريشن الفاينل بيكون اعلى من الكونسنتريشن الانيشال، لان الكونسنتريشن بتاعه بيزيد كل ما وقت الرياكشن زاد. تمام؟ يبقى the rate of formation of oxygen, the rate of reaction of formation of oxygen is equal to the change in molar concentration of oxygen divided by the change in time or the difference in time. Now let's talk about the mathematical expression of reaction rate. How to calculate reaction rate mathematically. Say we are dealing with a chemical reaction where reactant A undergoes some chemical changes and product B is produced. So that the rate of the chemical reaction would be equal the change in the concentration of A divided by the change in time T, or it can also or similarly calculated by using the concentration of B as the product. So it's the change also in concentration of B divided by the change in time T. Okay, if you are using a compound A as our reactant, we will start with A2, or the concentration, the molar concentration of A at time 2, minus the molar concentration of A at time 1, so that we are dealing with our chemical reaction. We are defining 2 points, T1 and T2. At T1 there is A, the molar concentration of compound A at T1, and the molar concentration of compound A at T2. So the rate would be the molar concentration of T at T2 and minus the molar concentration of A at T1 divided by the change in T, which is T2 minus T1. This value is what we call the change in the molar concentration of A, and this is what we call the change in time T. لو بصينا على الجدول دوت هنلاقي ان احنا عندنا different time intervals for a chemical reaction between butyl chloride and water. Chloride is in the aqueous solution form, and water of course is a liquid. When they react together they produce butyl alcohol and hydrochloric acid. This table gives us the different time intervals and the corresponding molar concentrations of butyl chloride, the reactant in this reaction. We have two reactants, that's water and butyl chloride. We are using the concentration of butyl chloride as one of the reactants. Okay, you can see T is starting from 0, then 50 seconds intervals, then starting with 100 seconds intervals, and then increasing the interval until we reach 10,000 seconds. The unit here is the second, while the concentration of butyl chloride is in molar, and we are given the corresponding molar concentrations of butyl chloride. Being a reactant, you can see that the concentration is reducing by time until we reach 0 molars at 10,000 seconds. We can calculate the average rate of this reaction by using the equation we have been talking about in the previous slides. We take two time intervals, two time values, and we take the corresponding concentrations at these times. We subtract them from each other and subtract time from each other, so we have change in concentration divided by change in time. And as long as we are using butyl chloride, so we can express the rate as the change in the concentration of butyl chloride divided by the change in time. This is the same equation we have been talking about. So to calculate the rate, we are using two time points. We will use this as T1 and this as T2. So this would be X at T1 and this would be X at T2. The change in concentration would be equal to X at T2 minus X at T1 divided by the change in time, which is 50 minus 0 to give the final result of rate. If we calculate the average rate throughout the whole reaction, as you can see, we used every two successive points as T1 and T2, and then used this and this as T1 and T2, and then again this and this as T1 and T2, and we calculated the different average rates throughout the reaction. If you look at the average rate values, you can see that the rate is reducing, and this is logic. The reaction starts with the highest rate because we have the highest concentration of reactant. And then concentration of reactant is decreasing, so that the average rate would be also decreasing. يبقى احنا هنا بنتكلم انه لو حسبنا الريت لكل 2 points في الرياكشن هنلاقي ان الريت بيبتدي باعلى حاجه خالص، لان دي اعلى كونسنتريشن احنا ابتدينا بيها في الرياكتنس. اعلى كونسنتريشن للرياكتنس هي البوينت الستارتنج بوينت بتاعت الرياكشن. بعد شويه بيبتدي الكونسنتريشن بتاع الرياكتنس يقل، فبالتالي بنلاقي ان الريت هو كمان بيبتدي يقل. هنلاقي ان اقل ريت هنوصل له هو اللي موجود في اخر نقطه خالص، اللي هي قبل ما نوصل للزيرو مولر كونسنتريشن للبيوتايل كلورايد. طيب احنا لو حبينا نعمل بلوت او كيرف يمثل الريت اوف كيميكال رياكشن، هيبقى شكله عامل ازاي؟ What if we want to express the rate of chemical reaction in the form of graph or plot? It will be in the form of a relationship between time in seconds, and that would be on the x-axis, and concentration in molars on the y-axis, and the concentration would be that of products or reactants according to what we would like to express or what's available in our values. Okay, as long as we are dealing here with the concentration of reactants, so we will find the curve declining or decreasing, or the slope is reducing by time, through time, because the concentration of reactants is generally decreasing as the reaction goes on. بما ان الرياكشن مستمر، فالكونسنتريشن بتاع الرياكتنس هيبتدي عالي ويبتدي يقل تدريجيا واحده بواحده، والشكل الكيرف هيبقى كده. And if we want to calculate the rate from this curve, we can do it at any point from the curve. If we want to determine the rate at this point, we would draw a tangent line using a ruler to draw a tangent line to the curve at this point, and take the two ends of the line and detect them on the curve. This is the first and this is the second, and on the corresponding values on t. So this would be t1, this point, and this would be t2. This would be x at t1, and this would be x at t2. We need to calculate the rate, so we can easily calculate the rate by calculating the slope of this line. The slope would be the difference in y's, the y values here, divided by the difference in the x's. So, measuring the slope of the tangent line to the curve at any point is equal to the instantaneous rate at that time. The rate at this point is called the instantaneous rate. يبقى احنا بنحسب الريت ازاي يا شباب؟ يبقى الريت من الكيرف بيتحسب ازاي؟ بيتحسب بطريقه سهله جدا. هنحدد البوينت اللي احنا عايزين نقيس عندها الريت، وبعدين هنرسم بالمسطره تانجنت مماس للكيرف عند البوينت ديت. والتانجنت لاين دوت هناخد فيه كده نقطتين، نجيب الاكسس بتاعتهم، يعني التو بوينتس الكورسبوندنج ليهم على الاكس اكسس، ونجيب التو كورسبوندنج بوينتس على الواي اكسس، ومحتاجين نجيب السلوب بتاع اللاين ده. طيب هو السلوب بيساوي ايه؟ بيساوي التشينج ان واي باي ذا تشينج ان اكس. فرق الوايز divided by فرق الاكسس. طيب فرق الوايز احنا هنجيبه من هنا، من الواي اكسس، وفرق الاكسس هنجيبه من هنا من الاكس اكسس. السلوب دوت هو هيساوي الريت at that point. All reactions slow down over time. دي حاجة ثابتة. This is a constant concept. It's not changing. All reactions decrease in rate or slow down over time because the concentration of reactants decrease also by time. Now we have, so far we have two methods for calculating the rate. Number one, the equation, which says that the rate is equal to the change in molar concentration, whether reactants or products, divided by the change in time. And number two, the curve, the graphical method, by calculating the slope of the tangent line to the curve. Okay, now we have two methods for calculating the rate, and later on we will have a third method, a third equation to calculate the rate. طيب يبقى احنا كده عندنا طريقتين لغايه دلوقتي بنحسب بيهم الريت، يا اما ماثيماتيكال عن طريق الايكويشن، يا اما جرافيكال عن طريق الكيرف زي ما قلنا. والبوينت اللي احنا بنحسب عندها الريت اللي بنحسبه في الحاله دي ما دام عند certain point كده في وسط الرياكشن بيبقى اسمه instantaneous rate. instantaneous rate. What about the instantaneous rate at t0? What if you are requested to calculate the rate of the chemical reaction at T0, at the starting point of the reaction, which would be the highest rate? احنا بنتكلم اننا بنحسب الريت عند الستارتنج بوينت بتاعت الرياكشن اللي هو هيبقى اعلى ريت ممكن نشوفه في الرياكشن دوت. طيب في الحاله دي هنعمل ايه؟ في الحاله دي صعب ان احنا البوينت اهي، صعب ان احنا نمد التانجنت في الناحيتين، ما ينفعش نمد التانجنت بره الكيرف كده. طيب يبقى احنا عندنا التانجنت في اتجاه واحد بس اللي هو هنا اهوت، تمام؟ يبقى احنا هنحسب من هنا من اللاين من النقطتين دولت، هيبقى النقطه الاولانيه اهي والنقطه الثانيه اهي. طيب هنجيب الكورسبوندنج ليهم على الواي اكسس، ادي بوينت 1 وادي بوينت 2، وبعدين هنجيب الكورسبوندنج ليهم على الاكس اكسس، ادي الx2 والx1 هتبقى هنا اللي هي هتبقى الزيرو. تمام كده؟ ونحسب منها الريت بنفس الطريقة بتاعت السلوب، ال difference of y's divided by difference of x's، والresultant would be the instantaneous rate at t0، أو بنسميه بقى ليه اسم تاني بما إنه at the starting point فهيبقى اسمه initial rate. What is initial rate? Initial rate is the instantaneous rate at the beginning or at t0. Okay, so now we have two terms. We have the instantaneous rate that's the rate at any point of the reaction, and we have the initial rate that's the rate at t0 or the rate at the beginning of the reaction. We have a third term that's called the average rate. The average rate. Average reaction rate would be the change of concentration between the beginning and the end of the reaction. It's the rate throughout the whole period of the reaction. The whole period of the reaction. We will start with T1 and T2. T1 would be 0 and T2 would be the end of the reaction. In this case, the rate is called the average rate. And that's different from the instantaneous rate. Instantaneous rate is the change in concentration over only a short period of time. Only a short period of time, divided by this short time elapsed, while in case of the average rate, we divide it by the total time elapsed during the reaction, the whole reaction time. Okay, so now we have the initial rate, we have the average rate, and we have the instantaneous rate. You must differentiate between the three. You must differentiate how to calculate any of these rates. Let's take an example. If reactant A and reactant B are combining together to produce a product. This reaction is expressed as a balanced equation that n moles of A equal plus m moles of B produce the product. In this case, the law of mass action states that the rate is proportional to the active mass of the reactants. So we have reactant A and reactant B. The active mass of reactant A is the molar concentration of reactant A raised to a power equal to the number of moles appearing in the equation. So the active mass is the molar concentration of A raised to the power n, while the active mass of B would be the molar concentration of B raised to a power of m. This is the active masses of these reactants. So the rate of chemical reaction is directly proportional to the product of the active masses or the molar concentration of the reactants. So that if we have two reactants like these, so that the rate is proportional to the multiplication of their active masses. If we want to remove the proportionality sign and convert it into an equation, we must add a constant. احنا واخدين طبعا الناس اللي واخدين ماس قبل كده عارفين ان انا لما يبقى عندي proportionality form كده، يعني الريت هنا proportional للاكتيف mass of A multiplied by the active mass of B. عشان احول دي لصورة mathematical equation بشيل البروبورشناليتي ساين واحط مكانها constant. الكونستانت اللي احنا حطيناه هنا اسمه small k. Small k is the constant here and would be called the rate constant. Okay.